All right, let's look at how to train a StyleGAN2 model on GCP. So I already have a video on how to do this on Colab. I've already done a video on how to do it on Paperspace. GCP is a little bit different, but like not too different. So if you've watched the other videos, you can probably just quickly fast forward or like skip around to find the right things here. First thing we want to do is just start up our server. So we're going to start this guy. Now there's a couple things with GCP. So GCP, because it doesn't out of the box have a static IP, and I've actually found it a little annoying to set up static IPs on this machine. We're going to be doing a lot of stuff directly in the command line, so it's a little bit more advanced than other things we're used to, but I think it's still going to be good to like learn this stuff. So the first thing you want to do is you want to bundle up your data set and put it on Google Drive. It's just going to be the easiest thing to do. So I have a folder here called Combined Floral. We can look at this on my local machine here, and we can see this is a set of images that are sort of like decently sized background flowers, most of the flower. You'll see the dimensions here are 768 by 1280, so we're going to look at non-square images today, showing how to set this up. So we're going to use the skyflynil repo. This does non-square images really great. There's also some nice directions in here, so we're going to work with directions directly from this. It'll be pretty straightforward. But now we should see our machine is set up here, so we're going to log in, open a browser window. This always takes a surprisingly long time. I feel like there might be a better solution here, but either way, we'll figure it out. All right, here we go. So this is now in our main folder, so we just ls here. You'll see that we have the skyflynil over here. The thing you'll also notice is that we are using our base anaconda. So the first thing we want to do is we want to actually activate our StyleGAN library. So we're going to type in Conda activate StyleGAN2. StyleGAN? Let's just try it and see. That works. Okay. So I couldn't remember if I named it StyleGAN2 or not. I didn't want to look up the line to figure out how to actually like list out all of your Conda environments. If you don't know what this means, I would go back and check out one of the videos we have on installing all this stuff. With GCP, you definitely want to use Anaconda because there's some real messiness behind the scenes of how Python works. This is just the cleanest way. Cool. So now that we have the right Conda build set up here, we're just going to move into our skyflynil folder, and I believe it's already in a thing called StyleGAN2. And if we ls this folder, you will see that we have here a folder called datasets. Now this is the folder that we want to put all of our TFRecords in. So the first thing we actually want to do is let's make a new directory, and let's call it raw datasets. So why do I do this? This is so I can differentiate my raw images from my TFRecords folders. This is just what I do. I make a folder that's like this, and now we want to cd into that folder. Okay, now the next thing is there's a couple ways we could do this. We could upload the zip file by hand, just using the upload file command. That's probably going to be pretty slow just because I'm on a local connection and I have bad Wi-Fi in my apartment, so whatever. So the way that I would actually recommend doing this is using a thing called gdown. And the way gdown works is that you find the ID of your file, and then you just pass that in, and it's going to download directly from Google Drive. What's nice about this is because it's a Google server to a Google server, it's going to be really fast. So this is only 266 megabytes, so it might take like a minute for us to actually transfer this over. So we're going to come over here, we're going to get shareable link, and you're going to turn share linking on. For whatever reason, Google doesn't let you actually like grab this. This is the thing I hate. I just did it. Okay, so you have to refresh this page. You can't, it's like, this is the most annoying thing. You can't actually grab, oh my god, seriously. Get shareable link, make sure your link sharing is on. When you like focus into this field, you can't actually grab just the ID. So you have to like copy this whole thing, and you have to come back over here, and you have to paste the whole command in, and then you've got to come over here and like delete this. Like, if someone from the Drive team is watching, can you guys please fix this? I know no one from the Drive team is watching this, but just in case. Okay, so now I have the ID of this file, and what I want to do is I want to type gdown --ID, and then this is the ID of that file, and I'm going to hit return. And look how fast this thing is downloading, 120 megabytes per second. That's amazing. Okay, so now, like, if I were to upload this from my computer, I'd get like 2 or 3 megabytes per second. Okay, so now this is in here. So if I do an ls in this folder, you'll see I have my zip file. So what do I need to do? I need to unzip, and then it's just combined floral. That's now unzipping all these, and I hope it kept the folder, because if it didn't, this is going to be annoying. And I will probably just restart this video because I don't want to deal with this. So ls, cool, it did. So combined floral is now a folder. If I ls combined floral, you'll see all my images are in there. Great. So now I can actually remove that combined floral zip file, .zip. So that just cleans it up. So now we've deleted that. So now I have this folder here that has all my raw images in it. So now I want to go back a folder to my main StyleGAN2 folder, and I'm going to come over here and I'm just going to look. I personally never remember the directions for this, but I'm going to grab these from what is in this repo. So detailed instructions on how to train your StyleGAN2 model. There's some special tips in here about using 1024 by 768, I believe. Yes, for image size 1028 by 768, you may choose, and we'll talk about this math in just a minute, you may choose 106 by 7 or 53 by 8. And the person who made this repo recommends you use the latter, so it's 53 by 8. So the first thing we're going to do is we're going to convert this to, and I'll explain this in just a minute, what these numbers mean. But first thing we're going to do is we're going to actually create our data set, so creating the TFRecords files. Basically the way StyleGAN works, it reads from a TFRecords file rather than reading raw images. Supposedly it's a little bit faster. I've heard debates about it, but I just do it because it's easier for me to remember. So we are going to pass in a command. This is the same as like your other traditional StyleGAN models. You pass in Python dataset tool.py, and then you actually, so usually we just do create from images. In this case, we're going to do create from images raw. And that's a special little command in this library that basically it reduces the number of TFRecords folders or files we need, and it makes everything move a little bit faster, so it's nice. The next thing we want to do is we want to do res log2 equals 8. I will talk about that in just a minute about when we actually start training, but this is the setup we need. And now we need to pass in 2 parameters. So the first thing we want to do is this is our, what's the folder name that we want our files, our TFRecords files to go into. So I am going to, oh man, I keep doing that, paste in dataset, which is where I want all my TFRecords folders to go, and then I'm going to call it combined floral. The next line we want to pass in is the untarred raw image directory. That just means what's the destination for your raw images, and that is /raw datasets, and then there is a folder in there called combined floral, right? So this is everything we need. So this isn't really that different than our previous like normal StyleGAN model, except for this command. So I'm going to run this, and it's going to convert all of my images into a TFRecords file. This shouldn't take too long because there's only like 800 images in here, so it's like pretty small. Yeah, that was really fast. I don't even know what what the holdup was there, because it actually converted those images really, really quickly. So if I do an ls datasets, and then I do an ls here, whoops, what just happened there? I named it the wrong thing. It should be dataset, not datasets. So ls dataset / combined floral. Okay, so you'll see the difference here is that there's only one file. And I actually think this is named wrong. I think it should be R08, but maybe I'm wrong. But anyway, if you're used to using like the basic NVIDIA StyleGAN model, you'll usually see like 02, 03, 04, 05, up to like 09. And that's just because this is using this raw command. You get a lot less TFRecords files, and it's supposedly faster. Okay, so I got sidetracked because I had to actually teach a class. So just as a reminder, where we are is we have uploaded our dataset. We've now converted it to TFRecords. There's one more thing we need to do before we actually can start training. and that is because the data set is 1280 by 768, we actually need to upload a new model to be able to transfer from. Now the reason we have to do that is because the model that is default set in here for transfer learning is 1024 by 1024, and you can't transfer learn from models where your data set, where the size of your model and the size of your data set don't match. And by size, I mean like the shape of the data images. So the model that I've uploaded, which is FFHQ, is meant for 1024 by 1024 square. This data set is 1280 by 768. So I actually need to grab another data set or another pickle file to transfer learn from. So we're going to do that really quickly here. So first off, just a reminder, here's where we are. We're going to move into the skyflynil data set, or sorry, repo, StyleGAN2, and return. And so again, if we ls here, we will see that we have our data sets, and we have a folder in here called results. And if I ls results, see there's a file in here called pretrained. For my own sanity, what I'm going to do is actually remove this file, in part just because this is like, I want to transfer using like just the latest off of this. So if I actually just do ls, and then, so like there's a file in here. So what I'm going to do is I'm just going to say remove rm. Can't believe I just tried to pronounce that. I'm going to paste this in here, and then I'm going to say network. So I'm actually just going to remove this file. Now, if you are following along and you know you want to do a square 1024 by 1024, just let me know, and there's a way around this, which is basically like, well, actually, let's just do that version. I'm not going to do this. So let's actually just rename this. So let's just call move. So if you've never done move before, you can also use the mv command to actually rename stuff. So what I'm going to do is I'm going to say move this file. Okay, interesting. It's, of course. All right, well, anyway, ignore that. So we're just going to retype this command, results / 000 pretrained / network. And then we're going to rename this. So actually what we want to do is we want to take this path again. So we're going to say results / 000, and then we're going to just actually type this out again. So network -snapshot. And then we're just going to like append at the end here. Ignore. So this is super hacky, but what it does is it actually renames this file. So I hit enter, and then I do. You'll see that now this pickle file is no longer called .pickle, it's now called .pickle ignore. This is a hacky way to have the algorithm, or the little script inside here that looks for the latest pickle file. It's going to skip this because it doesn't actually match the pattern it's looking for. This is stupid and it shouldn't work, but it does. What you can do is when you're ready to use this one, you can actually just rename this again and remove this. That's a fun little hack, but it totally works. So let's just do, we're going to move into this folder again. So see results / 000 pretrained, and now we're inside this folder. So now I need to find the pickle file that I want to pull from. So I just happen to have this pickle file here that we can transfer from. Again, the name is helpful here because it's already set up to be found using that latest script. So I'm just going to, once again, use gdown. I'm going to get the shareable link for this file, copy this, and then go back to my virtual machine. And we're already in the right folder, so we're just going to type gdown --id, and then we're going to paste this in, and we're going to have to delete all this crap because Drive likes to annoy me. So unlike the folder that I had to zip up, because this is just one file, I can just directly gdown this. Basically, you can only gdown a single file, so you can't really do a folder. You have to like go through every individual piece of it, so just zip a file if it's a folder. And there's our lovely quick download again. So if I ls inside this folder, you'll see now I have this one. It's going to ignore this file, and it's going to pick up from this file. And this is, I've double checked, is already 1280 by 768. So I think now we are finally ready to start training. So the first thing I want to do is I want to go back to my main StyleGAN2 folder. And now we're in here. So if I look again, you'll see there is a run training command. Yep, run training.py. So I'm just going to go over to this repo again because it basically already gives me everything I need. So in here is the run command that I want to run. So I'm going to take this and I'm going to make a couple small updates to it, but it's mostly ready to go. So this is Python run training. I only have one GPU. I have a P100 on GCP. The data directory should always point at your parent of the TFRecords folders. In this class, or like the way I structured, it'll always be /dataset. Config. So I'm going to go into a longer thing for config in a different video, but essentially the configuration is what type of network do I want. TLDR is either you want to use config E or config F, and it just matters. It depends on the size of your the image you're outputting to. So in general, like config E works well if you're doing something smallish, like 512 by 512. Because I got doing something bigger, I'm just going to use config F. It makes everything a little bit slower, but it tends to have a better improvement in the high-res sort of details. This is the line I need to edit, so it's dataset, your dataset name. So I actually need to make this say combined floral. Mirror augmentation. So I do want these images to flip left to right because they are the flowers. They should work fine left to right, but I don't want to use mirror augment vertical. So by ignoring and not adding that here, it defaults to false. So I'm going to keep flipping left to right on, but not top to bottom. Metrics, I'm going to do a whole video on metrics. I recommend for now just keep it to none. Once you've seen the video, you can decide if you want to use metrics or not. Total K images, 20,000 is fine. And then let's talk about this guy here. So the way this command works is you saw that when we previously created our TFRecords file, we passed this argument in. What does this mean? So log of 2 means it is a power of 2. So if I come up here and I say 2 to the power of 8, that is 256. So this is using multiples of 256. The width is 3 times 256, which is, just to prove I'm right, 768. And the height is 2 to the 8th by 5. So that is 1280 by 768. So basically this is how we're telling it what size it is. It's very important that your image dimensions for StyleGANs are either 1 by 128s or by 256s. So the default is actually to 7, and 2 to the 7th is 128. So you could have a, I don't know, what is times 9. So you could have it 1152 for a height, or you could have it, what's times 5, 640. So you can play with these dimensions. This repo recommends that if you are doing 1280 by 768, they use 8. That's because that 8th channel, I think, makes the network a little bit deeper, but it's also a little bit smaller overall. So just trains better is essentially the long-running thing here. So it's important that you actually know that when you're making your data set, that you cannot make anything that is not 128 by, or like not 128 or not 256. So like often people will tell me like, can I do a 16 by 9? Or like, can I do a 720p? Like 720 is not actually divisible by any of those numbers, right? So 720 divided by 128 is not a number you can use. 4K is also too large, so like that's not even a thing. So like you have to remember that it works with those dimensions essentially. Okay, with that in mind, so we've now like used all these call outs here. I think we're ready to start training this. So I'm gonna hit return, and I'm gonna hope that I see the line that picks up from this pickle. If I don't see that, that means maybe something's broken or I need to fix something, but we should be able to see it from here. So I'm just gonna hit return. And you'll see we're starting to convert some things. You're getting a lot of outputs here. Usually the first time you run this, it's a little bit slower than when you run this command again on the same machine because it's caching some files. So far, so good. You'll see the shape of this is 3. That's the channel, so it's RGB. It's 1280, which is the height, and it's 768, which is the width. And the range is 0 to 255. That's 256 colors, or like 256. That's just like the size that we can work with. And you'll see right here, loading networks from, and it's loading this from that correct pickle file. So we should be good here. I shouldn't get an error message about these shapes not matching. And this is the stuff that it needs to be cached. These are some custom CUDA commands that the NVIDIA StyleGAN folks have written. These get cached, so once you run the command again, this will compile much faster. And it won't really stall like this, it'll just quickly work. So we're still processing some stuff here. This is basically the output of the architecture. We're good here. I'm feeling pretty confident that this is going to work for us. One thing I'm realizing is I don't actually know if I need to run this in nohup mode for GCP. So what I might do just for my own sanity is once I know this was working, I might just stop it and rerun it in nohup just to be sure. But let's just see how this works and we should be good. So now we're building our TensorFlow graph. This is usually the last part before I know if I'm getting an error message. As soon as you get a message that says it's training for 20,000 K images right there, usually means we're good. There's one small thing you might run into before, like after this, that would be an error, and that's in case your data set somehow manages to have some weird, like cropped images that aren't actually 768 by 1280. It sometimes will sneak by the TFRecords creation and throw an error here, but that's pretty rare. So we'll just sort of see if this works. You'll usually know within a couple minutes because you'll get the very first pickle file produced from this because it basically produces a pickle file from its current status. So whereas it's going to be maybe another 40-45 minutes before your next load, you can sort of like keep an eye on this and just make sure everything's working. I'm actually going to quickly Google. Yeah, I do think I'm going to have to run this in nohup. Okay, that's fine. So what we're going to do is we're going to wait till... Yep, this is what I want to see. So you'll see here, this is outputting. Basically, this is saying, hey, I'm picking up from the K image of that previous file. It's fine. I might want to reset this at a later point, but it's fine. Telling me how large my mini batches are, the time that it took to compute basically from the start of this to getting that first pickle file. This will be much shorter than the next one, which will be like 45 minutes. And then seconds per tick, like this is just some timing, and it lets me know how much memory I'm using. This might realistically be 16 gigabytes. I find it always underestimates this, and it might be because there's some other functions that are using more than this. At this point, I know this is working. I'm gonna hit Control-C. I'm gonna hit Control-C. There we go. Sometimes you do it twice. When it's done, it should take me back here. Also, I see that there was an issue here. That issue was, which I'm surprised actually worked. When I stopped my recording to go teach my class, I didn't actually reactivate the right the right environment. That's pretty shocking that that actually worked. It shouldn't have. Anyway, whatever. Okay, so now that I'm back in my StyleGAN environment, I'm going to go back and run this script, but instead of what I'm going to do is I'm actually going to come to the very beginning of the line. I'm going to hit Control A, that's going to take me to the beginning of the line, and I'm going to write in nohup. Now, what nohup does is it makes sure that I'm not, make sure that when I close this browser window, that it doesn't stop the command. It's actually going to keep working behind the scenes. And that's what I want to do. I want to leave my machine on. If I were to turn off my virtual machine in GCP, it would actually stop the command. But I actually just want to disconnect from this SSH and actually keep it running in the background. That's something I've done previously with Paperspace. It works fine. It's good. There are other ways around it. You could install GNU. You could install tmux. If you're interested in that, I can record a video on how to do that. But for now, this will work fine. The one thing to remember is that when you hit return, you are not going to see anything. It is just going to spit out like nothing at this point. It's because it's writing it all to a file called nohup.out. And basically what I'll probably do is I'll check in like a couple hours on this, and I'll like show you how to quickly assess whether this is working. So I'll record another video or another like step to this video just to show you this is working. Okay, so this is actually only like 5 minutes since the last time I recorded this video. One thing I want to talk about is, so this is now running in background in nohup. So basically what I did is I was running that command, I closed my SSH window, and then I opened a new one. And you'll see like you don't pick up where you left off. Like that command of nohup, that run training command, is nowhere to be seen here. And that's because it's essentially now been detached. It is running a background process on the GPU, but like you don't see it here. So a common thing that people ask me is like, how do I find this? How do I stop it? Like whatever it is. So let me introduce to you nvidia-smi. So when you type in nvidia-smi, I'm having trouble saying that today, you will see that we now have a command here. So this spit out all this information. So if you're interested, you are running a CUDA driver 4.10. You are using CUDA version 10.0, possibly. This one's, it's too much to get into, but basically, like, yes, you're running this thing. Next, you know you are running a Tesla P100. It says it right here. You see that it's 74 degrees Celsius. You can ignore that. The next thing you want to know is how much of your GPU are you using. So you have a 16 gigabyte GPU, right? And ideally, you want to use all of it as much as possible, because if you run any less, you're wasting your money. This is using 15.7 of a 16.2, so you pretty much can't do any more than this. Like, this is pretty good use. Then the last thing you want to look at, and this is the important thing, is this is your process. So here is GPU process. It's running on this GPU, which is the Tesla P100. You can see because this ID is 0, 0. Here's the process ID. This is important to know if you want to quit this. And then you'll see this is Python, and it's running 15.7 gigabytes of a GPU memory usage. Sometimes, depending on the type of machine you're on, you might see another command here, and it'll be running like 200 megabytes, like something really small. But basically, this is your command running on the GPU. Now, if you want to kill it and you want to start like, start over, or like you decide you want to stop this machine, the way to do it is kill -9 and then type in the PID, and the PID is what's here. I'm not actually going to run this because I don't want to stop this command, but this is what you would do in case you want to check to see what's running. This is really helpful too, because especially if you own your own GPU, you might want to run this just to keep an eye on things. So for example, the GPUs I have, sometimes they get really, really hot. Sometimes they hit 85C. Anything around 85 to 90C is when your machine is going to start to slow down, and you have a risk of actually hurting your GPU. So you want to make sure this is running less than that. And I'll talk in a different video about how you might control that. But basically, it's helpful to run this and just keep an eye on things. It's also good to just see where your wattage is at. It's good to see how much of your memory you're using, like that sort of thing. So all this command is very, very helpful. I use it pretty much every day as I'm doing machine learning stuff to just keep an eye on this. Anyway, I'm not going to run this command. I just wanted to add this as like, here's the thing to know about. Welcome back in 8 hours once we've sort of been looking at things, and we'll take a look at what we have, and then we might stop the machine and decide what to do from there. So it's been about 24 hours since I restarted my machine or restarted the training. So let's take a look at what our results are. So I'm back inside of the skyflynil folder and inside of StyleGAN2. And if I just hit ls here, you'll see that, or actually let me just run nvidia-smi. So we are still running. This is fine. I'll just keep letting this run for a little bit longer. I've already downloaded the image fakes or latest fakes from this, and you can find those in, if you go to ls results, you'll see basically your latest number here is going to be your latest file. So I'm just going to copy this really quickly and go cd results / and then you can look inside this folder and you'll see I have a number of fake outputs here. So I just grabbed a couple of these and let's take a look at them in Finder. So downloads. So let's start with the earliest one. This was literally like the first fake tick after transfer learning, and remember it transferred off of some weird oily paint things. So you get these like very like swirly artifacts, lots of little textures inside of the flowers, that sort of thing. This is pretty normal for your very first tick. If this were trained on faces, it would look like faces. But this is actually pretty close to what I would expect in terms of the very first setting, and actually it's pretty good already. I was pretty surprised by how close it was already to what I would expect to see. Next fake is like 80k images later, and we can talk about what k images mean in another video. You'll see it's getting closer and closer to the right structure for things. The flowers are still very swirly, which is normal, that's to be expected. It does take, I find it takes about 500k images or thereabout to get to like a really good point. And that can depend on your data set and other things. But this is actually already like, these flower structures are already pretty close to what I would expect. Going up, this is only 40k images, let's sort of skip that. So this is I think one of the latest. Let me make sure of that. Yeah, this is one of the latest. And it is really only 100k images in, I think, or like I forget exactly what number I started with. But it's probably 100, 200k images in. It's pretty close by to what I would expect. So this is already looking pretty good. I mean, some of these are not perfect, and some of these things are also trained on, like, I don't know the truncation values of some of these. So these might be a really high truncation value, in which case this is what I would expect to see for those. In other cases, we're seeing some really good looking stuff. Like, obviously, like, I pretty much know that the flowers will never look perfectly flower-like, but these are looking pretty good. So I'm pretty happy with these. This is one of the things we could look at, which is, and probably helpful to look at in this video, is let's download the nohup.out file. So if I go back, let's see, probably 3 folders. Nope, only 2 folders. And I hit ls, you'll see my nohup out here. Now the way to download these again is you just hit pwd, that gives you the full path, and then you go to download file, and you go /nohup.out and download. It's really easy to download this, or it should be really quick because it's just text. Open this up in your text editor, and I'm going to scroll to the bottom and sort of work my way back up a little bit because I know there was a previously closed training here. So what do I see here? So there's a couple things to look at in this file. There are what they call, this is sort of the text output every time you hit what they call a tick. A tick is a certain number of k images depending on what you've set your mini batch to, amongst other things. It always varies a little bit. But you can sort of read this as a list of how things are going so far. So in this case, this is listing the k image. So it started at around 1200. So realistically, what was I looking at here? So I was looking at 12208. So this is about 200 plus k images in. Mini batch, so this is the mini batch. It is 32. I'll talk about mini batches in a different video. Essentially, what I sort of look at is how long does it take to train a tick. And on a P100, it looks like it takes about 40 minutes. That's pretty common. I mean, I wouldn't expect anything faster. On a V100, you probably will hit like 30 minutes. So it is faster, but you have to sort of balance out the cost with how quickly it performs. You can see some other metrics here about how long certain things take. I'll go over this in further detail in a different video, but it's just helpful to know to like sort of look at this and just sort of see how it's going. So it has been almost a full day since I last restarted this training. So looking at this, you can just sort of see like how things are going. There's no metrics output from this, and that's because I turned metrics off. In another video, I'll probably show what it looks like when you actually run metrics. But I think this is just about it. This is pretty much everything I want to cover for this video. So you should now be able to train a pretty base skyflynil StyleGAN fork. So you should be able to do non-square pretty easily, and then you should be able to sort of keep an eye on things and see how things are going as you progress. I'm going to let this model run for a little bit longer, and I'll probably share it in the Slack channel when I'm done. All right, thanks.